Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guide in preparation for the Chapter 2 test that's going to be coming up on Friday, tomorrow, actually, probably today. If you're checking this right now, you're probably going to be taking it as soon as we get done here. So, being able to go back and forth between fractions, decimals, and percents. If I take any fraction, say the fraction 3/4, that can be changed to a decimal by doing the division. 3 divided by 4, how many times does 4 go into 3? 0 times, and we want a 0 in the ones place, remember, because this fraction has a value less than 1. So then we work through the process again. We'll add a 0 there. So 4 goes into 30 7 times, and 7 times 4 is 28, which leaves you with 2 left over, and 4 goes into 2. Now we got to bring down a 0, don't we? So 4 goes into 20 5 times. So this is where it terminates. So the decimal equivalent would be 75 hundredths. Now this is, it's a good idea to say it as the name, because 75 hundredths is another way that you could write the fraction as well. And this particular version of the fraction is critical for the percent, because 75 hundredths is the definition of 75%. So we know that's going to be 75%. Now the shortcut, if you are converting from a decimal to a percent, you just move the decimal 2 places to the right, and that becomes your percent. If you're going from a percent to a decimal, then you go in the reverse order. If you're changing from a decimal to a fraction, you just write it as a fraction out of 100 or wherever it terminates, and then simplify the fraction. And if you're going from fraction to decimal, you do the division. So let's take a look at the answers. I'm not going to work out every single one of these. I'll just choose a few. Here's the 75 hundredths in decimal form, which becomes the fraction. Here is the percent, which would become the decimal. So 34 or 3/4, 75 hundredths, 75%. They're all equivalent to each other. Changing a decimal number to a percent. Remember, you could either move the decimal 2 places to the right, or you can actually write the name of it. 8/10 by rule means 8%. 3/5 becomes the same as 6/10, and 6/10 is equivalent to 60 hundredths. So 3/5 is 60 hundredths, which would be by rule 60%. Okay, to change from a percent to a decimal, you just move the decimal 2 places to the left. Or if you wanted to write the percent as a fraction, 87 hundredths has the same name as the decimal number, 87 hundredths. So we want to be experts. There are going to be times when you're given a percent and you'll want to do a calculation with it, so you'll want to change it to either its decimal or its fractional form. There'll be times when you have a fraction and you want to rewrite it as a percent. We need to know how to use proportional reasoning for that. For instance, let's take 3/5 again and show how we would use proportional reasoning to make that into a percent. 3/5 is going to be equivalent to some fraction with a denominator of 100. Once we identify the numerator of this fraction, we will have our percent. So what do you multiply times 5 to give you 100? That would be a 20. So we'll also have to multiply 3 times 20 because this is a giant 1. So 3/5 times 20 over 20 gives you 60 hundredths, which by definition is 60%. All right, integer problems. Let's take a look at some of these problems. If you're going to add 4 plus -2, take 4 positives and 2 negatives, and then identify all the 0 pairs. What do you have left over after you eliminate the zeros? 2 positives. So the shortcut to this, so that you don't have to keep writing all of these pluses and minus signs for the integer representations, is to just ask the question, are the signs the same or are they different? If the signs are different, you have to do a subtraction. So do we have more positives or more negatives? We have more positives, and how many more positives than negatives do we have? 6 minus 1 is 5. So that means that you would have had 1, 2, 3, 4, 5, 6, and just one. So when you take away the 1, 0 pair, you're left with 5 positives. Okay? If you've got a situation where you're adding two numbers that have the same sign, -5 plus -8, 1, 2, 3, 4, 5, there's -5, 1, 2, 3, 4, 5, 6, 7, 8. There are no 0 pairs because you're only adding together numbers with the same sign. So you're going to add the numbers and you're going to keep the sign. So you have a total of 13 negatives there. Here you'd have a total of 12 negatives. Here you'd have a total of 27 negatives. So when the signs are the same, you add the number and you keep the sign. When the signs are different, you're going to do a subtraction and keep the sign that has the greater absolute value. So do you have more positives or negatives? How many more positives do you have, or how many more negatives do you have? And in a situation like this, adding 7 plus -7, those are opposites of each other, so their sum will always be 0. And now for the last problems. Being able to multiply fractions together is a matter of multiplying a numerator times a numerator and a denominator times a denominator. You can use the area model to help you understand why we do what we do, right? Here's an example of us taking 1/3 of 1/6 or 1/6 of 1/3, however you want to think about it. So if you take and shade in 1/6 of this rectangle, then take 1/3 of it, that represents 1 out of the 18 total squares that are created in that area model. So 1/18 is the answer. So in all of these instances, your job is to multiply numerator times numerator, denominator times denominator, and then simplify the fraction to its simplest form. If you have any questions on how to get these answers, please let me know before you take the test, because I want you to understand this. The test is worth 100 points. You need to have this mastered. Okay? All right. Take care. Bye.
Hey, feeling good